I copy the same 4x plus the magic number that helped me to complete the square. Okay. Okay, by the way, 4, no? Remember 4 divided by 2 square. That's the formula. 4 divided by 2 is 2, 2 square 4. Plus no, minus. Because it's the hyperbola, look, it's minus. So you see in the y part, okay, the great common factor is 4, negative 4, actually. As you factor out negative 4, we have inside the parenthesis y squared minus 8, okay, it's minus because minus times minus plus. And 32 in my mind is 8 and 4, 8 times 4. You factor out 4, stay 8. Of course, with the opposite side, plus another box. And inside that box, we have 16. Because 8 divided by 2 is 4 squared 16. Now, in the right hand side, we have, well, this 64 can move to the right, and you include 2 numbers. Be careful with the number. It's obvious that the first one is 4. But the second is not 16. It's 16 times negative 4, que es negative 64. Be careful with this, because when you introduce artificial number, but inside the parenthesis, actually, the total number that you introduce was the multiplication, that number times the greatest common factor that you put outside. Okay, so the factorization that part is x plus 2 squared. Where come from this 2? Square root 4, no? Minus 4. The factorization, this is y minus 4, right? Square. In the right hand side, I can see que 64 and negative 64 cancel and stay only 4. Almost, we finish. The last step is divide the whole thing by 4. Because remember, right hand side must be 1. Entonces, my equation is x plus 2 squared over 4 minus y minus 4 squared over 1, because 4 divided by 4 is 1, equal 1. And this is my equation, okay, by the way, is equivalent 100% with the original. It's exactly the same algebraically. However, in this case, I don't see anything totally lost. However, I am clear now. Okay, for example, a is 2. Remember, the hyperbola, a is defined. So let me recall, my formula is x minus h squared divided by a squared. A is associated in the hyperbola always with the positive part, minus y minus k squared over b squared equal 1. Es obvio que A es 2. Es obvio que B es 1. Es obvio que the center of this hyperbola is located at the point minus 2, 4, right? And the foci, or the focal distance, no? Is c squared is equal a squared plus b squared. C squared is equal 4 plus 1. Fi. Therefore, C alone is radical 5. Okay. Entonces now I realize also que my hyperbola is horizontal. How do you know? Because the positive part is associated with the x. So our hyperbola look like that. Bam, bam. So the axis of transversal is parallel to the x-axis. Okay. Now the vertex, one of the vertices is located in this point. This point and this point is the vertex. And this point is located in the center, no? It's negative 2,4. And this distance I determined que was 2. Okay, entonces 2 in both directions. 2 in both directions. The vertex is located at the point, bueno, es 0,4 and negative 4,4. And they say y component of the center, but you decreasing and increasing, so basically you affect the x component plus 2 and minus 2 plus 2, minus 2 plus 2 is 0, and minus 2 is negative 4. And the foci is located here, over there, always inside. And this distance is radical 5. Radical 5. Therefore, the foci is located at the point negative 2, comma, negative 2 plus radical 5, sorry. And negative 2 plus or minus, no? Plus or minus. Radical 5, comma 4. So you, well, so you put in decimal, I put in decimal approximation. And the asymptote is here. Two asymptote. The asymptote is located at the point y minus k, k in our example is 4, this is k, this is h. Entonces minus 4, plus or minus, b over a. The formula is y minus k is equal plus or minus b over a, parenthesis x minus h. In our specific example, b is 1 and a is 2, 1/2. Open parenthesis, x minus h, pero h is negative 2, double minus becomes positive. This is the formula for this. End the story. Now, immediately, I go to decimals to see the graphic. How do you find the foci? Okay, the foci is from center. Okay, from center, you move because the foci lie is a point. Que lie in the transversal axis at the distance c from the center. Make sense? Answer me, yes or no? Eso, bueno. Okay, let me try to see the decimals, no? Switching to decimals. Okay. Do you see decimals? Okay. Again. Okay. Center. Negative 2, negative 4 in green color. Vertex. 0,4, negative 4,4. And this is the, the corner of the reference rectangle. It's easy because this segment is A and this segment is B. In our example, B is 1. And the foci is a weird number because it's irrational, radical 5. Okay. And radical 5 is approximately 2.236. Any question? Any question? Super clear or super confusing? Clear. Okay, I want to erase the board because we are doing the question number 4. Question number 4 is, let's compare this. Summation from K1 to 16 of the one expression that is 2K plus 7. Let me check it out. The reaching of problem, yeah, absolutely. Okay, you apply the property, of course. The property of the summation symbol is a linear operator. Linear operator means, guys, okay, when you have addition or subtraction, you can separate, and also the factor you put in the front. is a linear operator. In mathematics, you can find in calculus several linear operators. Linear operator. In this case, linear operator. Entonces K1 to 16 and just 7 alone, no? Something like that, right? Entonces I immediately recognize that we're using that formula. The formula is, you know, summation from K1 to M of K is equal M plus 1 divided by 2. This is a formula to do fast. In our specific example, is these two I copy. The formula have M, que is 16, N plus 1, que is 17, divided by 2. These two is cancelled, why not? And multiplication is 272, at least the first part, that part. And that part is super easy because you apply the property, que is the multiplication, this number. And this number, because actually the thing we are doing is adding 16 times. To say 16 times 7 is 112. And the total answer is 384. End of story. Easy, piece of cake. Any question? No? So I want to complicate a little bit. Now we have summation. Okay, no question. From K3 to 5 of K squared minus 10. We can do, in this case, let's do it in both ways. We expand, and we're using the formula. Either way, let's do it by curiosity in both ways. Suppose this summation, I break it down, summation from K3 to 5 of the K squared minus summation, another summation from K3 to 5 of 10. Okay, let me compute it separately this. Because, remember, our formula, see, we make a decision to using the formula. Okay, the formula is summation from K1 to N of K squared. The formula is N plus 1 to N plus 1 divided by 6. Is the formula. But what's the problem? The problem is, suppose I want to compute the summation from K3 to 5 of K squared. The problem is that the supposition of the formula is K starting 1. But okay, no problem. I can break it down like that. Look, summation from K1 to 5 K squared minus subtraction, summation from K1 to 2. Okay, K2 is 1 less than this. Because the completed collection is 1, 2, 3, 4, 5. And you subtract 1 and 2 to say it's from 3 to 5. It makes sense, right? Okay, now ready to apply the formula. This formula 2 times is 5 multiplication by 6, que es n plus 1, multiplication by 11, que es 2 times 5, que es 10 plus 1, 11, divided by 6. Subtraction. Again, the formula is 2 times 3 times 2 times 2 is 4 plus 1 is 5 divided by 6. Okay, this is 55. Okay, the first one is 55, and this is 55, F50. F50. Okay, this is the final answer, no? No. This is only the answer for that part. The answer for that part is 50. Okay, another way to do this. You say, well, professor, but this is easy in another way because it's not too long summation. And we start, for example, 3, suppose summation from K3 to 5 of the K squared. I can suppose get 3 squared plus 4 squared plus 5 squared. This is 9, this is 16, and this is 25. and we get exactly the same answer, 50. In this case, it's easy in that way. However, if I put 50 here, it's not easy. It's complicated, right? And we use the formula. So what is the final answer? What is the final answer? Well, I need to compute that part. I need to compute this summation. Summation from K3 to 5 of 10. Actually, this is 30. It's obvious 30 because you're adding 10 plus 10 plus 10. But how many times? How many times? Well, from 3 to 5, include both, is 3 times. O sea, es 10 plus 10 plus 10. This first 10 is for k equal 3. This second 10 is k equal 4. And this is k equal 5. It's the upper bound. And it's the lower bound. And between 3 and 5, count both endpoints. We have 3 elements, no? That's 30. Another way, another shortcut is you take 10 and multiplication by 5 minus 3, 5 minus 3 plus 1. Okay, be careful, plus 1 is 2 plus 1 is 3, is exactly the same. What is the final answer? Well, the final answer is 50 minus 30, 20. End the story. Okay, easy, easy, easy. Everything okay? Everything is confusing? No? Come on, guy. This is a moment. No? Okay. No. Okay, Sean. Let me try what number? Number 6. Number 6 is about the arithmetic sequence. The what information is given the A sub 1 is minus 4, semicolon, D is 9. And they want to find A sub M, so the element located in the position arbitrary M. Oh, remember the name of this is A sub M explicit formula, BAM. And specifically, one position is 6. Okay. The only thing I need to remember is the formula. The formula for the A sub n in general is A sub n is equal to A sub 1 plus n minus 1 times d. We have one specific example. Everything is given. A1 is negative 4. And d is 9. The rest is try to put a more elegant way. This formula minus 4 plus 9m minus 9 is 9m minus 13. 9, no A sub n. Sorry. 9 times m minus 13. This is the formula, the particular specific. This is the general formula for any. But in our specific example, the formula is like that. Okay, super. Now I want to find A sub 6. Well, it's easy. Plugging in 6 here. 9 times 6 minus 13, 54. Minus 13, 41. Boom. Final answer. This is arithmetic sequence in which is given the initial, the first element in the sequence, and the common difference. Number 7 is similar. Is A1 is 0, and D is 1 over 10. It's a fraction. Okay, no problem. Remember, in general, this number is all real number. Positive, negative, fraction, decimal. And the question is the same. The question, yeah, it's the same question. I need to find A sub n formula and A sub 27. 27, yeah, 27. When you have the formula, you just plug it in 27 and that's it. So the formula is, again, I copy A sub m is equal to A sub 1 plus n minus 1 times d. In our specific example, a sub 1 is missing, it's 0. I have to say state n minus 1 divided by 10. Or parentheses, whatever you want to write, it doesn't matter. And 27, this is my formula. This is my formula. So a sub 27 is equal to 27 minus 1 divided by 10. It's 26 divided by 10. And we can reduce a little bit. So you put in fraction and decimate away 2.6 or 13 over 5, no? When you divide it by 2, top and bottom. This answer is correct. This answer is also correct. Either way. Okay, this was the question number 7. Okay. Any question, guys? I told you the sequences and series, well, no, es easy topic en pre-cálculo, ¿no? Pero es en calculus 2, the teacher complicated a little bit your life. Suppose now number 8. Number 8, find the sum. Number 8. In number 8, you find the sum of this. 6 plus 12 plus 18 plus that. Remember that symbol indicates that it's continued forever, following the same pattern again in the first number indicated by using your imagination, no? And the last guy is 480. Stop the summation. Okay. Okay, entonces identification quickly that we are working with the arithmetic sequence because the common difference is 6. Now you're subtracting 12 minus 6, 18 minus 6. The D is 6. And A sub 1 is 6. And A sub n is 480. The problem is that I don't know what is the position of them, but I can find. So using the famous formula, A sub n is equal to A1 plus n minus 1d. Okay, this is 480. This is 6. This is n, que is exactly the only guy that I don't know. And d is 6. So basically, this is 6 plus 6n minus 6, no? Oh yes, entonces cancel out. Entonces, in order to find the m, you divide by 6. So big as 80. I discovered in this summation we have 80 elements or terms, doesn't matter. It's actually a summation for the first 80 elements. And the formula is n over 2. Well, the formula in general, a sub m is m over 2 a1 plus a sub m. And you average the last and the first and multiplication by m. Okay, this is the idea for it. In our specific example is, let me see, 80 over 2 is 40, 6 plus 480. Calculator, the answer is 19,440. Boom. Summation, arithmetic sequence. Okay, let's go to the question 9. The question 9 is also summation. In the question 9, we can do that. We can do that in a different way. Question 9. Can you scroll up a little bit? Yeah. In the question 9, we can do that problem using arithmetic sequence or just using the summation formula. Exactly, we studied the last time. I don't know why in my paper, you see, in my paper, I am doing in that way, like a consideration que es arithmetic sequence. It's basically summation from n equal 1 to 27 of the negative 4 m minus 2. Okay, by curiosity, let's do it in both ways. Under the consideration que es arithmetic sequence, how do you know what the clue can give me information? Well, it's clear because arithmetic sequence, when this expression is linear, it's a line, it's arithmetic sequence. When this expression is exponential, entonces es geometric sequence. Suppose n equal 1. I try to expand a little bit that part. Es obvio que es negative 6, so A1 and negative 6. For n equal 2, plugging in 2 is 2 here is negative 10, no? Because 2 times 4 is negative 8, and negative 2 is 10. For n equal 3 is negative 14, no? A3 and negative 14. Okay. Now you try to find the common difference is negative 4. Okay, entonces now conclusion, it's arithmetic sequence. We can do the problem under the consideration que es arithmetic sequence. Okay, and the information is A1 is negative 6 and D is negative 4. Okay, entonces suppose que I want to find A sub 27, que is the last guy. This continues, bam, until n equal 27. Okay, entonces the formula is A sub 27 is equal A1, okay, A1 is negative 6, plus n minus 1, que n is 27, no? 27 minus 1, que is 26, multiplication by negative 4. The answer is A27 is negative 110. Now, finally, I applied the formula summation the 27 element is, well, in general, is A sub m is n over 2 A1 plus A sub m. In our specific example is 27 divided by 2, parentheses, minus 6, que es the first guy, plus, or minus, well, in this case, plus minus, no, it's minus, actually, because it's negative 110. The rest put in the calculator is negative 1566. Okay. Well, another student can do that using summation, no? But I take advantage, because, you know, arithmetic sequence. Si es arithmetic sequence, that's the solution. Suppose you make a decision to do it that way. Let's try. You trick like summation. Entonces you apply the summation as linear operator. Entonces ahí es negative 4. Summation from n equal 1 to 27 of m. Minus summation from n equal 1 to 27 of 2. Entonces you apply the formula. In this case is negative 4. Entonces 27 multiplication by 28 divided by 2. Minus, entonces this is 2 times 27. Let me try my calculator. My calculator is 2 times 27 times 28. See, the problem was, okay, simplification, no? This and this. The actual in my calculator, I put 2 times 27 times 28. And the answer is 1512. Minus, S minus, of course. The 27 times 2 is 54. And then so now, this plus this. Okay, is negative 1566. Either way, guy. The way you can see, I try to illustrate both ways because you see the potentially of the geometric sequence, you know? Now, how you recognize a geometric sequence? Because the expression A sub n is linear. See, the expression of A sub n is exponential because it's geometric sequence. Any question? I'm doing too fast because I suppose it's a review, no? It's only so the concept is clear, no? The technique and the specific example is the thing that we are discussing now. Okay, everyone follow me? Now let me see. Queen, Frank, Banks, Sean, Artist Betancourt, okay. Yailin, Yancy, Dustin, Lauren, Karen, and Yasmin. Okay, erase the board. Let's move on to number 10. I see. Okay. Okay, super. Now let's go to number 11. And now number 11 say, no, number 10. Number 10, yeah, you're right. Thank you. Number 10. Number 10 is find the fifth term of the ES sub n term of the geometric sequence whose initial term is given and the common ratio is given. Okay? Okay. O sea, this is the package says A, but it actually says A1, no? It's the first. Therefore, semicolon and common ratio is 1/3. Okay, entonces now is wait. The formula is A sub m is equal to A1 paréntesis R. No necesariamente paréntesis. R A sub 1 times R n minus 1. It's the formula. In our specific example, A sub m is 4 parenthesis 1 no, because it's a fraction, 1/3 raised to the n minus 1. We can manipulate it, we can if you want. Suppose que, you know, 1 is a magic number when you raise to the n power of 1, and then at the top we have just 4 divided by 3 n minus 1. This is another possibility to express the same idea. Let me write more clear this. This is 3. We have big board, not necessarily write too small. It's another possibility. Okay, so now they want you write the first 5 for n1, for n2, for n3, for n4, and n5, the first 5th element. Entonces, for the n1, bueno, es 4 divided by 3, 1 minus 1, wow, pero 1 minus 1 is 0, and any number raised to the 0 power is 1, entonces the answer is 4. 4 divided by 3, 2 minus 1. 2 minus 1 is 1, entonces 4/3. For n equal 3 is 4 divided by 3, 3 minus 1, que es 2, and 3 squared is 9, entonces 4/9. And so the next is 4/27, and the last one is 4/81. This is the sequence, geometric sequence. Do you see the mathematical law is exponential? Exponential decay or exponential grow depending the common ratio. The common ratio is less than 1. It's decreasing. Remember, guys, we have two exponential like that. Whoa. Common ratio. Well, actually, the sequence is not function. Es a function, but it's discrete function. But we study in general, when you study exponential, the continuous law. This is when the common ratio is greater than 1. Si the common ratio is less than 1, it's decreasing. And the common ratio is decreasing. In this case, it's decreasing. You see that the number is smaller, smaller, smaller. 11. 11 is similar. A1 is negative 2. And common ratio is negative 5. The ratio should be positive, should be negative. When the situation happens, when the ratio, common ratio is negative, the element in the sequence alternating positive, negative, positive, negative, positive, negative. Okay. The formula. A sub n is equal to A1 R n minus 1. In our specific example, A sub n formula is negative 2, parenthesis negative 5 raised to the n minus 1. Now leave it like that, yeah, why not? N equal 1, n equal 2, n equal 3, n equal 4, n equal 5. And you plugging in one by one. N equal 1 is negative 2, it's obvious, right? It's negative 2 because 1 minus 1 is 0, negative 5 raised to the 0 power is 1, so stay alive only negative 2. And for n equal 2, entonces different, it's 2 minus 1. Okay, let's do it. Negative 2, I have no idea. Minus 5 raised to the 2 minus 1. Entonces es obvio que 2 minus 1 is 1, and negative 5 raised to the 1 power is negative 5, times negative 2 is positive 10. Do you see it's alternating? One guy is negative, one guy is positive, the next guy is negative, positive, and negative. Because the common ratio, the reason that this situation happens is because the common ratio is negative. For n equal 3, it says negative 2 is negative 5 raised to the 3 minus 2, 2 is square 25 is negative 50. And n equal 4 should be positive, minus 2, negative 5 cubic. It's one more, so see, the n is 4, the exponent is less than 1, entonces 3. And negative 5 to the cube power 125, negative 125, times negative 2 is positive 250. Okay, in this case, increasing, alternating, but increasing, because the common ratio is greater than 1. Okay, entonces 555 is negative 2 times negative 5 raised to the 4 power. I put in my calculator, the answer is minus 1250. This is 11. Any question, guys? Super easy or super complicated? Okay, let's move on to 12. 12 is 12. Let me copy. It's find the sum. Find the sum. The sum is sigma from K1 to 5 of 2/3 raised to the 2 to the K power. And this look like, in my mind, like a geometric, no? Because actually it's exponential. However, I know A sub n is equal to A1 R n minus 1. So I am not sure, I am not clear who is A1 and who is K. K no, R, sorry, the common ratio. So I propose you the fantastic idea, always. You plug it in for K equal 1. K equal 1. I put N here, but actually my problem is K. It doesn't matter what variable we use in like an index. Entonces, 2/3 multiplication by 2 to the 1 power. This is 4/3. Okay, this is A1. So I know that my formula is AK is equal 4/3. And the common ratio, I have no idea. Let me try K2. It's 2/3 times 2 to the second power. Okay, it's 8. This 4 times 2 is 8/3. Entonces, en mí dice, you want to continue, K3, K4. Pero actually, I know que es geometry sequence by the shape of the formula, que es exponential. And the common ratio is 8/3 divided by 4/3. Es obvio que es 2. Wow. Entonces, the formula is 2k minus 1. Wow, this is my formula. However, they want the summation. The summation is summation the first 5 elements in this sequence. And we have formula for this. The formula is A1, the S sub n in geometry is A1, parenthesis 1 minus r to the n divided by 1 minus r. This is my general formula, but in our particular example, I want to find x5. Pero I know que A1 es 4/3. Y I know que R is 2. 1 minus 2 to the 5th power divided by 1 minus 2. Bueno, this is 32 minus 1. This is minus 31. And this is negative 1. When you put everything together in the calculator, the answer is 124 divided by 2. Any question, guys? This is just a formula. Just a formula. Let's do one more. Similar, very, very similar. 13. A summation from K1 to 4 to the 1/2 raised to the K minus 1. Okay. This is similar, pero actually we are doing something interesting. One shortcut. I know that the formula for the A sub K or A sub n, depending on the variable you consider index, is A1 R n minus 1. And this looks like similar to this. And we compare. Wow, I realize that A1 is 1 and common ratio is 1/2. Well, suppose that you don't see this. And suppose that sometimes it's not obvious. Like this example, for example, was not obvious. And this example was not obvious. So my recommendation always is you expand. Suppose K equal 1. We start in 1 always, not in 0 and 1. No, actually the summation starts in 1. Is 1/2 raised to the 0 power. This is obvious 1, exactly, we predict. And for K equal to is 1/2 raised to the 2 minus 1 que es 1 is 1/2. And the obvious que the common ratio is 1/2. 1/2 divided by 1 is 1/2. Super. Now summation of the 4 elements, because the upper bound is 4. Is A1 is 1. Multiplication 1 minus R is 1/2. 1/2 raised to the 4 power, no? Yes. Wow. 4 power. Divided by 1 minus 1/2. Okay, this is 1 is invisible. This is 1 minus 1/16. And this is 1/2, no? This is 15. 15 over 16 divided by 1/2. Value, flip it. The answer is 15 over 8. Is the final answer. Super. Any question, guys? There are many ways. You need to be smart. Sometimes it's clear the information. Sometimes it's confusing. But when it's confusing, so some people, I don't know why, prefer compare this expression and this expression and determine who is A1 and R. This is good. This is good. But sometimes hard and sometimes confusing. I highly recommend in Calculus 2, when you take Calculus 2, I recommend you expand a little bit, 1, 2, you know, get exponential, not necessarily do K3, because I know that the common ratio stays the same. And determine who is A1 and determine who is R. This is, in my opinion, the best way. Okay, 14. 14 is, you see? 14 is determine whether the infinity geometric series, we are talking about, so basically 14, we have 5 minus 5 over 3 plus 5 over 6 plus, bam, 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 bam. Actually, this is not plus, this is minus because I suppose it's alternating, no? It had alternating. So you see that the first guy is positive, and the second is negative, and the third is positive. I suppose that number 4 is negative, no? Make it sense, right? Okay. Okay, so immediately I try to identification, okay, we are working with the geometric, or no? So you divide. Divide negative 5 over 3 divided by 5, no? Positive 5 is negative 1/3. And one more time happen 2 important situations. Situation number 1, when the common ratio is negative, the series alternating, positive, negative, positive, negative, positive. And when the common ratio, absolute value of the common ratio is less than 1, the infinity series, is the infinity summation, this is from k equal 1 to infinity something, a sub k, is convergent. Convergent is the name to classify, no, this idea, and the verb is the action is convergent. So it is convergent. It converges. A converge to what value? Well, converge to the value that is capital S without M, no M, because this is the limit when the n approaches to infinity of the x sub n. And I determine that this formula is A1 over 1 minus R. A1 is 5. 1 minus 1/3. R is 1/3. This is R. Okay, to analyze the convergence or divergence, you find the absolute value. But in the formula, no. In the formula, you put minus 1/3. Entonces, plus 1/3. Entonces, this is 5 divided by 4, no? 4/3. Okay, flip it, 15 over 4. This is the infinity summation. And it's convergent. This is the most important information. It's convergent because it's geometric series, and the common ratio is absolute value is less than 1. Otherwise, no. Otherwise, it diverges. That's it. Suppose it's arithmetic, no, never converge. Only geometry is the only. Okay? Because it looks like exponential like that, no? Decreasing. And yes, arithmetic, never, because it's linear. And linear is, you know, when you go see the as low as positive, go to the positive infinity, and c as low as negative, go to the negative infinity. Never. This is totally divergent, and it's the only possibility we have converged. And the geometric series when the common ratio is greater than 1, bam, 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 is also divergent, convergent, and divergent. So two conditions to be geometric series and the common ratio actual value, of course, positive or negative, is less than 1. In calculus 2, we study, this is one particular case of the series. Another series que is not geometric and also is convergent. Pero in pre-calculus, we study only that. Okay? 15. 15, 15, 15. 15, 15, 15. 15 is, well, let me erase the board. 15. 15 is, well, it's crazy. 15 is 13 plus 17 plus 19 plus 21 plus total. If you divide this, never you get the same answer. Entonces, en aromática you discard no geometric, entonces diverge. Divergent means que S is infinity positive or negative. Well, in this case, positive. Because you're adding number, okay, increasing forever. It's positive infinity. Si maybe decreasing forever, it's negative infinity. Okay, to say you only determine convergent divergent. I repeat the idea. Only converge en pre-calculus the geometry series whose common ratio, the actual value of the common ratio is less than 1. Otherwise, no, is divergent. Divergent means increasing forever or decreasing forever, and no limited, no bounded to any value. This idea is clear or is confusing? Convergent or divergent? This idea comes from, guys. Yes, it's a clear. This idea comes from for the physics. When you study the lenses, for example, we have different kind of lenses. Look, we have the lens like that. It's a glass. It's a lens, right? And for example, the ray of the light is coming like that. Boom, boom, boom. And this lens may converge this adds to the one specific point. By the way, it's a focus again, similar to the parabola. Okay, this is convergent lens. However, divergent is another lens like that. Okay, when you the light of the sun, okay, by the way, is parallel the rate. In this case, diverge. Look, never meet. Diverge. Converge, diverge. Converge, diverge. However, in mathematics, converge means that you go to one specific value when the n approaches to infinity. No specific value. When the n approaches to infinity, go to the positive infinity or negative infinity, diverge. Okay, let's go to the last question, que es mathematical induction. Because we are doing the problem of the binomial theorem, class. 16 is proof using mathematical induction. Okay, 2 plus 5 plus 8 plus plus 3n minus 1 is equal n over 2, 3n plus 1. Okay, let's go. Remember this, the first step is the basic step. Is prove somehow that x1 is true. And x1 means for n equal 1. And n equal 1 means the first element. This is 2. In the right hand side we have 1/2 because n is 1. 3 times 1 plus 1. 3 times 1 is 3 plus 1 is 4 divided by 2 is 2. This statement is true. Okay, we finished the basic step. Now inductive step. In the inductive step, you assume, supposition, x sub k is true. And this is intermediate value. Okay, intermediate value between 1 and m. Then I have no idea, I increase it forever. Okay, so now I copy exactly the same original expression, but you replace n for k. Okay. Now I try to create the expression for the a sub k plus 1, que is the next after this. Well, this is exactly the same. Plus 5, plus 9, plus 8, sorry, plus da 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 da. I copy this, exactly the same, que is 3k minus 1. But you include one extra, que is the next. And the next is 3 paréntesis, double paréntesis, k plus 1 minus 1. Okay, so I focus in that part because this in one corner I copy, this is 3k plus 3 minus 1. Actually 3k plus 2. 3k plus 2, yeah. Entonces I copy again. 2 plus 5, either way, guys. This is 3k minus 1 plus, now this is 3k plus 2. Okay, stop for a moment in the left hand side. I move to the right hand side. In the right hand side we have k plus 1 divided by 2 and 3k plus 1 plus 1. Bueno, 3k plus 1, entonces 3k plus 3 plus 1 es 3k plus 4. Entonces es k plus 1 over 2. Actually, this parenthesis is 3k plus 4. But I know, under the supposition, that this part is exactly this. K over 2, 3k plus 1, plus 3k plus 2 should be equal to this. Okay, don't touch for a moment this. I manipulate a little bit. That part. Okay. I recommend. Can you, no, I don't know, find the least common denominator too, no? So when you find the least common denominator, we have k times 3k plus 1 plus 2 times 3k plus 2. Okay, now we have 3k squared plus k plus 6k plus 4 divided by 2. We have 3k squared plus 7k plus 4 over 2. Okay, stop. Now I move here. Why not you apply FOIL here. This is 3k squared. This is 4k. This is 3k. And this is 4. Bueno, okay, entonces we combine like term. 3k squared plus 7k plus 4 equal to. Now you get this statement completely true. Entonces, what is the idea in discrete mathematics, que es logic? The idea is, look, I suppose que SUK is true. Y under this supposition, si A sub k is true, and A sub k imply A sub k plus 1 would be true, and the reason it's true is because this is equal to this, is the identity, no? Mathematical induction say que this is equivalent to say x plus 1 is true, alone, without this link, without this connection. So now it's obvious que this continues forever, for k plus 2, for 3, for 1, and so on. End the story. This is the idea, mathematical induction, fantastic. We use it to prove something weird. Any question, guy? Everything clear? You see my face now? Okay. Listen. Now, I want to send right now the final test. The final test is completely optional. Si you are good student, can get A. You don't need to take the final. No, the final is only for the student can improve. Okay, you need to show me your work, no multiple choice. Okay, it's cumulative, everything from the chapter 1 to chapter 5, everything together. Now, everything is due tomorrow, April 28, because April 29, I grade the test 5, and the student can make a decision to do the final. Okay? And you stay here, and please let me know si you receive or no the final test. I say now. Okay, you receive, you can leave. That's it, guys. We finished. I love this subject. This is my favorite, right? I enjoy teaching with you this semester. Okay, maybe sometime we take with me another class. Okay. And also, yeah. Thank you for reminding me. Sean say, and the final and the test 5 and the Alex. Let's do the same day. Yeah. You're right. Yeah. Okay. Bye-bye.